Today we're going to go over functions. More specifically, this unit covers functions word problems where we have to determine how to write multiple functions in terms of other functions. When we do that, an example would be like if we have f of x, g of x, and h of x, all given formulas for each. Well, we have to decide how we would write each function with addition, subtraction, multiplication, or division um, based on the given information of our word problems. So that's the first thing that we're going to be doing. The next thing that we'll be looking at today is how to analyze trigonometric graphs and determine the components of those graphs based on word problems. And I think we've done some of this in previous units as well. We're also going to look at the end behavior of other types of graphs, mostly exponential functions. And then finally, we're going to analyze literal equations where we're given an equation with only letter variables. And then the goal is to solve for a specific letter using algebra. So for all of these, this unit is it should be review of everything that we've covered so far in this course, um, except that it it tends to lean more towards word problems where we have to define what our variables are in those problems, and we have to analyze some of the word problems with graphs to determine what is happening in these graphs. So I think this is a good summary for this course in terms of looking at word problems and figuring out how to translate them. So the first part is modeling with function combination. Sophia expects the number of cows C on her farm T years from now to be modeled by the function C of T is 30 times 2 to the T. Additionally, she expects the supply of hay F in tons that her crops can provide for each cow T years from now to be modeled by the function F of T is 8 times 1.5 to the T. Let H be the total yearly amount of hay produced in Sophia's farm in tons T years from now. Note that the hay produced on Sophia's farm is used exclusively to feed her cows. So when I first saw this problem, I thought it was quite challenging because we have to identify what C of T, F of T, and H of T is representing in terms of the variables. So first of all, let's start with that then. So C of T, that's just the cows. That's just how many cows are on the farm. F F of T, this one's a little bit more challenging to identify what it is. So it says she expects the supply of hay F in tons that her crops can provide for each cow. So the hay that can be provided for each cow is the function F of T. So hay per cow is another way that we can write this. And then for H of T is the total yearly amount of hay. And that tells us very clearly there, right here at the last paragraph. So this is the total hay for the year. So now we have to decide to write a function h of t with c of t and f of t. What operation or operations do we have to do to make h of t a true statement? So we're saying h of t is the total hay. So we really need to figure out now what do we have to do with cows and hay per cow to make that equal hay. So we want this to be hay equals hay for our final equation. So h of t equals, and now we have to figure out what operation we have to do to make it equal hay. on the side with C of t and F of t. And so if we look at it, we can say cows times A per cow, because cows and cows would cancel, and then we're just left with H of t is equal to the hay. And that was our original statement there, that the H of t is the total hay. And so we just multiplied C of t times F of t. So this first part's going to be C of t times F of t. Now it says to write the formula in terms of t. And so to write the formula in terms of t, we're just going to write what C of t is. That's 30 times 2 to the t times F of t was 8 times 1.5 to the t. Some of these you can simplify, but I think for this one we can just leave that as our answer. So all I did was just write what C of t and F of t is, and then we multiplied them because that's what our function is telling us to do. All right, so the second example, function combination. So that first example I think was fairly challenging. This next one's a little bit easier to decipher. It says Aditi is participating in a walkathon fundraiser. Two anonymous donors agree to donate money according to the distance that she walks. The money A in dollars that she receives from the first donor for walking D kilometers is given by the formula A of D equals 12D. The total money T in dollars that she receives from both donors for walking D kilometers is given by the formula T of D is D squared plus 20D. Let B be the money that Aditi receives from the second donor for walking D kilometers. So let's define what these equations mean. So A of D is the first person donating. And T of D is the total donated. And B of D is the second person's donation, or the second person donating. And so it wants us to write a formula for B of D in terms of A and T. So the total donated, we can say T of D, it's equal to what the first person donated plus what the second person donated. And it doesn't say anybody else made any donations, so it's just those two people donating. Okay, and then we just want to solve for B of D. We're just going to subtract A of D on both sides. So we get B of D is equal to T of D minus A of D. So that's going to be part one for this. It's going to go in our answer box there. And now it wants us to write this in terms of D. So again, we're gonna plug in what these values are that they gave us for T of D and A of D. So it said T of D is D squared. So B of D is equal to D squared plus 20D. And I'm going to put these in parentheses. And the reason is when we subtract A of D, this is minus 12D. If this was more than just one term and we did minus, we'd have to put this in parentheses so that the minus would distribute to both terms. But this is only one term, so I guess we didn't really have to have parentheses, but it is good practice. So now we can drop the parentheses. And that's just like that. So now we have D squared plus 8D for our final answer. And you could factor this if you wanted to. And that would be if you factor out a D, you'd get D plus 8, uh, d times d plus 8. So that's part two. So there's part one, and this is part two. Okay, let's look at one more of these here. It says Rocio predicts that the amount of corn in bushels produced on her farm can be modeled by the function C of t is 80t plus 1,000. The price per bushel of corn is modeled by the function P of t is 0.03t plus 5. Let I be Rocio's predicted total income from producing the corn t years from now. So let's define what these functions are. So C of t is the bushels of corn. I'm just going to write bushels. And P of t is equal to dollars per bushel. And I'm just going to write it like dollars per bushel. Okay, and then I of t, that's the total income, or um, we can just say this is the total dollars for I of t. So now we have to figure out what math operation do we need to do to make an equation where we have I of t equals something with C of t and P of t. I of t is dollars equals, and then we have to figure out, well, what do we have to do to make this a true statement? We have bushels, C of t, and we have dollars per bushel, P of t. And we would just multiply. This is very similar to the first problem. The toughest part about these problems is identifying what these functions represent so that we can cancel anything out if necessary. So now we have dollars equals dollars, which is a true statement. So we now can say I of t is equal to C of t times P of t. So that's for part one. Part one. Kind of ran out of room writing it in that box on the first example, so we'll write it down here like this. Now it wants us to write a formula for I of t. So we're going to do the same thing. Again, we're going to write parentheses around each function's value. So C of t is 80t plus 1,000 times P of t is 0.03t plus 5. And it's very important that you write parentheses around there, especially when we have more than one term defining the function. So now we're going to do the distributive property or the FOIL method. We would get 2.4 t squared for our first term plus 400t plus 30t plus 5,000. And we just simplify, combine the like terms. We just get 2.4t squared plus 430t plus 5,000. And that's part two for writing the formula for I of t in terms of t. And the reason that you would want to do this is so that you could, if you had these formulas, you could find what t is using the quadratic formula or with factoring if you were able to factor. Okay. Moving forward, we're now going to look at the periodicity of algebraic models. And this was discussed earlier in this course. I think the periodicity is fairly straightforward for these, but it is good to look at some word problems and try to understand the x and the y-axis and just checking to see which graphs represent the problem. This is a little bit difficult to see all of these answer choices, but hopefully you can see that. It says a bunny is released from a cage and hops away along a straight path. Each hop covers a horizontal distance of about 1 meter and a vertical distance of about 0.4 meters. Which of the following graphs could model this situation if X represents the bunny's horizontal distance from the cage and Y represents the bunny's height above the ground? So X is horizontal distance. We know X is equal to 1 for each bunny hop. And for each bunny hop, Y is the vertical distance, 0.4. So we just have to find which graph matches this. And we can see that each hop is on the graph here with these different hops. You can see it on each of the times that the bunny hops. It would follow just like how a bunny is hopping. Uh, so if we look at where X is equal to 1, we can see that from here to here is one space on graph D, and the height is 0.4 on graph D. So it's got to be graph D. None of the rest of these match that scale. All right, I think that was a good warm-up question for trigonometric functions. Let's look at another one here. It says, Dakota is watching the tides off the coast of Cape Cod. For 2 days, Dakota records the height of the water h in feet. His results are shown in the graph below, where t corresponds to the number of hours after 12 a.m. According to his research, how much time passes between two consecutive high tides? So at the high tides would be at the maximum or the peak of our function. So here's a high tide, here's a low tide, here's another high tide, and the cycle repeats itself. And so we just want to know how much time goes by. Well, time is on the x-axis, and so the time is from here to there. And it looks like we're at about 3 on our time for one of our times, and the other time looks like it's at 16. So we find the distance between there, which again is just the difference of the 2 points, and it's the absolute value of the difference of the 2 points. So we would have now negative 13 as absolute value of negative 13, which is equal to 13. So 13 hours go by between the two high tides. All right, let's take a look at one more of these. We have another trigonometric function here. It says some people believe that biorhythms can help explain one's emotional, intellectual, and physical aptitude on a given day. And just kind of a side note, biorhythms are a pseudoscience that uh, 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 claim to tell you what your mood is going to be, or how smart you're going to be on a certain day based on when you were born. It's not true. It's a pseudoscience, but it is based on a trigonometric curve. So we have the curve for this, and it says it models the physical biorhythm P for a person born on day T equals 0. And it says how long is one cycle of the physical biorhythm? Well, remember, one cycle is from peak to peak or from trough to trough. So that's one way we can, or two ways we can find one cycle. Let's do peak to peak again for one cycle. So this first coordinate is at, we're going to say 6, 1. And the second one is at 28, 1. So we're going to do the same thing, find the absolute value of the difference between the two. And we get absolute value of negative 22, which is equal to 22. So 22 days is the cycle for the physical biorhythm. All right, let's take a look at end behavior next. End behavior is asking us what's happening at the end of the graph, or what is the graph approaching after a certain amount of time. It says this person posts a funny video on their blog, and V represents the total views that this person receives after it's been posted for T days. Based on the graph, we want to know how many views Jackson's video is going to receive in total. And so if we look at this, it looks like this is sort of leveling out at a certain value. So if we continue down uh, where t is getting larger and larger to infinity, it appears that it's approaching y is 200 or v is 200. So it says, based on this trend, the end behavior is telling us that there's a limit at 200. So we can say it's leveling out at 200 or approaching a limit of 200. Okay, here's another one. It says, initially there were 20 wolves living within a nature preserve. As the time increased, the population of wolves P increased rapidly at first and then slowly began to approach 50. So rapidly at first, then slowly approaches 50. So approach 50 is not getting to exactly, but very, very close. And this is something that we see in calculus with the idea of limits. So we want to find something that's growing very fast and getting very close to 50. Cannot be A because it's at 50 and then it's going down. B is going very fast, but it looks like it's approaching 40, so not B. And then C, it would be linear. It's just going at a constant rate. So this one's got to be D, where it's going up very fast, and then it's almost going to get to 50, but it's not quite getting to 50. All right, let's take a look at one more of these. Next one says, Elena knows that Leah has a garden with an area of 100 square meters. She does not know the specific width and length of the garden. The graph below represents the widths that correspond to possible lengths of Leah's garden. As the possible width of Leah's garden increases, what does the possible length approach? Okay, so it looks like as the width is going up, the length is going down. It also looks like as the length goes up, the width goes down. So she only has 100 square meters to work with. So if one goes up, the other goes down in terms of length or width. So it says, as the possible width of the garden increases, what does the possible length approach? Again, we're wondering, what is the end behavior of this? So what is this eventually approaching or getting very, very close to? So the width, if we went way out to 100, say, or close to 100, the width would be approaching 0. It wouldn't be possible for the width to be 0 if we're doing the area of something, but it would approach 0, get very close to 0. Also, a negative would not make sense in this because we're talking about area. Okay, so our next section is on literal equations, and we have to know how to manipulate formulas with literal equations when we have multiple variables. This says to rearrange the formula and solve for C. And it gives us what the formula represents in terms of profit, net sales, and cost of goods sold. But if we just look at the main part here, it just says to solve for what C equals, given that P equals S minus C over S. So the first thing that I would do is multiply by S on both sides. So we're going to times by S times by S. So now we have SP is equal to S minus C. We can subtract by S on both sides. We get SP minus S equals negative C. And now we're going to times by -1 on both sides. And when we do that on the left, it's important to put parentheses around this because we're multiplying both variables by -1. So now this is negative SP plus S equals positive C. And we have our formula for this. So we can write that as our answer, or if you want to go one step further, you could factor out a negative S or an S, but let's factor out a negative S. That leaves us with P minus 1 in the parentheses when we divide by negative S, and that equals C. I'm just going to write or, because we can write that either way for this problem. Okay, we've got a couple more of these. It says the following formula gives the volume, where A is the area of the base and H is the height. And this is a formula that we see in geometry. Volume is 1/3 area of the base times height. And we want to rearrange the formula to solve for what A is. So we can rewrite this like this. We can say V is equal to 1 times AH, or just AH, over 3. So that's one way you can rewrite that. We're going to multiply by 3 on both sides. That gives us 3V equals AH. And we're going to solve for A. We just divide by H and divide by H. That gives us 3V over H equals A. Okay. You could also rewrite it like 3 times V over H equals A. That is also acceptable. A third way you could write this, just kind of a side note here, you could write this like 3V times 1 over H equals A. So those are 3 equivalent statements. Notice how we can write fractions this way, because this is very helpful when we're getting into things like doing physics equations and geometry. All right, I think we've got a couple more here. This next one is a physics example. I'm going to erase this so we have some more room. And this is a formula that we see in physics. Also, just kind of a side note here, all of our answers are case sensitive when we're putting in our answers. So if it's an uppercase, just make sure that you're writing an uppercase. If it's a lowercase letter, make sure it's lowercase. All right, so to measure an object's kinetic energy, uppercase K, the equation for that is 1/2 mv squared, where m is the mass and v is the velocity. And in physics, it's often helpful to rearrange a formula before you start entering in values. So that's another reason that we would need to move our formula around. So we're going to solve for what m is. So we have k equals mv squared over 2. That's the same thing as 1/2 mv squared. And then we're going to times by 2 on both sides. That gives us 2k equals mv squared. We'll divide by v squared on both sides. That cancels those out on the right side. And we have m equals 2k over v squared. And we'll just leave it like that for now. I think we saw enough examples of different ways we can write our final answer. Just remember, everything is case sensitive. So when you're putting this into the answers, make sure you have an uppercase K for your answer and a lowercase v for the v squared. Make that a little smaller. Okay, this is our last example. It says the following formula is used in economics to find a company's net income, N, where P is the sales price, V is the variable cost, S is the sales and volume, and F are fixed costs. And we want to rearrange this formula to find what S equals. So I know we've done a few of these so far, but this next question I think is important because it highlights that we can divide by a binomial. So we can add f to both sides. We get n plus f equals s times quantity p minus v. Now you could do distributive property, But if you did that, you would be going in the wrong direction to solve for what S is, because we already have one S over here. It's being multiplied by P minus V, and we can treat this P minus V as a single term. So it's two terms in parentheses, but if you treat it as a single term, you can divide by P minus V with parentheses. And now the P minus V cancels on the top and the bottom of the fraction on the right-hand side of our equation. So now we're left with S equals N plus F over P minus V. It's usually a good idea to write all of these in parentheses as well when we have a plus or a minus on the numerator or the denominator. That's just kind of a side note as well. All right, so hopefully that was helpful to look at how to model equations with word problems, looking at some graphical examples of trigonometric functions and looking at limits and end behavior as well as literal equations.